Hey guys, this is Isaac209, and then yeah, the reason I'm not playing Gorilla Tag is because here's this kid that asks, does Pluto have an atmosphere, or does Pluto have a magnetic field, wherever it is? Right here, not this one, right here, this word. Well, asks that, what did you say? And he's asking me why Pluto does not have a magnetic field, or does Pluto have a magnetic field? And when I realized that, I answered the question, but the reason I didn't speak it on camera is because that was off camera. So I'll teach you why Pluto does not have a magnetic field. So Pluto does not have a magnetic field. We already know that. So I'm just teaching you though. So Pluto does not have a magnetic field. Why, you may ask? It is bigger enough for. It is the biggest dwarf planet in the dwarf. Wherever the dwarf groups. Um, it's because Pluto radius is about one one eight one. Oh, I'm kind. No, never mind. I'm not writing it. I'm struggling writing it. Pluto radius. Okay. Short. There you go. That's the radius of Pluto. That means it's the size. Add that on that. So that's like gotta put my calculator right there. That's about one. There you go. I think that's the size. So that's about like 1.868 Earths. So yeah, that's the size of the surface area. So this is the surface area of Pluto, and this is the flattening of it is about 0.1% of it, and the mean radius is right here. So compared to it, it's like that's the dimension of it. So it is a sphere, but it is smaller. So magnetic fields won't able to spawn that small object because. So here's how it works. So here's rule 2. Planet. Okay. Where's my? Okay. Planets only happens when bigger and smaller. So that's 1 and that's 2. So planet only happens when magnetic fields when it forms. That means gravitational pull and mass of it. So the mass had to be so big and just the perfect size, it would form its own magnetic field. I had to draw over it, sorry. But for planet 2, like smaller object like moons, asteroid, and dwarf planets, they're a bit smaller. I'm gonna put random numbers right there. They're a bit smaller. And if it have gravity, then that means gravity is very slow. And for its size, it's very small. So that means gravitational pull of its own surface, do not happen due to its size and due to its own dimension of 2,376.6 and 1.6 kilometers. I think kilometers maybe, or yeah, km, wherever it is. So that means yeah. So for surface tension is about 17443 times x. So if we calculate to my calculator, if we calculate down, okay, there we go. Okay, the answer is about 1 point Earth, Earths. So it's about like 0.35 Earths of its mass. So that means that it's smaller than. If it's bigger than, it would add up. It will add up by like tens, tens, and plus tens with squares and squares and squares. That means it would turn into a gas giant or a rocky planet. Either way, if it's have enough mass for it and perfect size, it would open its own magnetic fields. But if it's smaller and then bit like an asteroid size, like moons, asteroids, and comets, then it would not happen to its own available surface with protection from solar winds. And for rule 3, for my own Pluto, for Pluto of it, oh, it's not porn. I thought I have it. This should, why does it always keep doing that? There. So Pluto will have, like, gravity. Sorry, I messed up my speech right there. I'm kind of struggling saying it. It does have gravity, but it does not have a magnetic field. So the answer is no, because size compared to the moon, I can't draw the right size. I forgot. I don't have the picture of it. Like the moon or its own planetary binary or other dwarf planets that's smaller than Pluto does not have a magnetic field. But if it's for rocky planets like Venus, Mars, Mercury, and including gas giants, like, hold on, let me try to erase this. Oh, now it's bold. Like gas giants, then yes, it would have its own gravitary, or not gravitary, magnetic fields and gravitational pull from planets. That means its size would be smaller or would be larger. So when size does matter is because when size has to be like angle from other objects. Like if you're holding a magnet, a small magnet, and if you're holding a big magnet, like a strong magnet, pretend that the small magnet is Pluto and the large magnet is a planet. So if we put a test next to a paperclip, with a magnet that's smaller, then it will go slowly and it will not have enough force for it to pull. But for bigger magnets, then it will instantly pull. Even a miles away, if it's bigger, then it will still pull. From its force, that will be stronger. So compared to its small magnet, Pluto would be the same thing as a magnet. So Pluto don't have a magnetic field. But it still have mass though. But yeah. That's how I teach it. Thanks for watching and then subscribe.